Welcome to our solar system. For centuries, we have imagined it as a celestial clockwork, planets orbiting sun in a near perfect, flat, elegant circles. This model, the very image of the cosmic harmony, is what the classical physics and early astronomy taught us. But what if I told you that the beautiful image is broken? Look closer. The specific, especially at the giants, Jupiter, Saturn, Uranus, and Neptune. Their orbits aren't perfectly flat. They are slightly tilted relative to each other and relative to the plane of the inner planets. They are also a bit more elliptical than our standard formation that model predicts it. It's not dramatic tilt, but it is enough to have puzzled astronomers for decades. The standard theory of the planetary formation, where everything collapses from a smooth disk of gas and dust, say they should all be perfectly coplanar. So what happened? What pushed them off course? The answer may lie with an uninvited cosmic guest, a rogue planet. This isn't just a stray comet or a wandering asteroid. We're talking about a massive sunless world, possibly up to 8 times the mass of Jupiter, that once tore through our fledgling solar system like a wrecking ball. These rogue planets or free floating planets are common in our galaxy, ejected from their own birth system, and one of them, new simulations suggest, came calling. To understand the impact, we need to travel back about 4.5 billion years when our solar system was young. The sun was surrounded by its birth cluster, a densely packed neighborhood of other stars. This is critical because in that environment, close stellar and planetary encounters were far more common than they are today. The giant planets were still settling into their final position, and their orbits were likely more tidier, much more circular. Astronomers didn't just guess this happened, they used sophisticated computer models known as the N-body simulations to test the hypothesis. They simulated tens and thousands of flyby scenarios where a massive interstellar object passed near our outer planets. They varied the intruder's mass, speed, and distance of the closest approach. What was the goal? To see if any scenario could reproduce the wonky orbits we observe today. And the result was stunning. The most realistic scenario involved an object somewhere between 2 to 50 times the mass of Jupiter and the best match to our current orbital structure. An intruder about 8 times the mass of Jupiter, passing incredibly close, potentially within 1.7 astronomical unit of the sun, which is closer than Mars is today. And that is a breathtakingly close call for such a massive visitor. What does the close pass from an 8 Jupiter mass object do? It delivers a powerful gravitational kick. Imagine trying to run a race and a giant abruptly shoulder checks you. The giant planet orbit, Jupiter, Saturn, Uranus, and Neptune would have been violently unsettled. The intruder's gravity would have, number one, increased their eccentricity, pulling them from a perfect circle into slightly more oval shape. Number two, tilted their orbit plane, giving them the slight noticeable slant that we see today. This entire process happened in a flash, astronomically speaking, before the rogue planet's hyperbolic trajectory sent it rocking back into interstellar space, leaving chaos in its wake. Now, the researchers estimate the odds of this specific orbit warping encounter happening during the solar system early life in its birth cluster was roughly 1 in 9,000. That sounds low, but considering the sheer number of rogue planets in the galaxy, potentially trillions, and the dense nature of the stellar birth cluster, those odds aren't prohibitive. It shows that we didn't need a guaranteed event, just a slim chance that over billions of years finally rolled the right way. This rogue planet hypothesis offers a compelling alternative or supplement to other theories, like the existence of Planet 9, which has been proposed several times. Planet 9, if it exists, would also have a tilted and eccentric orbit. Could this same ancient gravitational chaos be responsible for shaping the orbits of Planet 9? Or could the rogue planet be the initial gravitational disturber that set the entire outer solar system in motion? The study highlights that the substellar objects, which is objects more massive than planets but less massive than stars, are the key here, long overlooked actors in the evolution of planetary systems. Our solar system is not the tranquil, static place once we thought it was. Its history is, very disturbing one, marked by violence, ejections, and massive gravitational interactions. The subtle, broken beauty of our giant planet's orbit isn't a design flaw, it's a scar. It's a lasting signature of an ancient, colossal flyby, an encounter with a rogue world that, for a brief moment, broke our solar system, ensuring its permanent, beautiful imperfection. So, friends, what do you think? Did a rogue planet break our orbits? Let me know in the comments below. And if you enjoyed this cosmic deep dive, please hit that like button and subscribe for more astronomy mysteries. Thank you for joining live. Thank you for watching. I will catch you again in the next one.